In Java 1.4, a new I/O package was added to the Java Software Development Kit. Now they called it java.nio, and the package was described back then as an improvement to Java I/O, and that's because the classes in the package perform I/O in a non-blocking manner. Now Java NIO was also meant to fix some of the inherent problems developers could run into when using the java.io classes to work with the file system. Now the java.no classes fall into one of two buckets, those that deal with the file system and also those that deal with reading and writing data. In this video we're going to start looking at the classes that read data from and write data to a data source. Now when using classes in the java.io package, a thread will block while it's waiting to read or write to a stream or buffer. However, threads using the java.nio class or classes will not block. In other words, they're free to continue executing, and consequently you could really say that java.nio was introduced as a performance improvement. With that said, many developers have argued that the java.nio package was a step backwards. And in fact, there's examples on the internet that people have shown that blocking I/O, which is in the java.io package, is often faster than the non-blocking I/O in the java.no package. And the discussion on threads and blocking, etc., is covered in the threads section of the course, by the way, just in case you haven't seen that section of the course yet and are wondering what that's all about. Now, also working with the java.nio class is more complex, and you'll see that when we go through to start writing some code. Now, as has happened with other additions to the Java language, many developers still prefer to write code using the older java.io classes, and you may very well decide to do that as well, but I do feel it's important to understand the new way of doing I/O with the java.nio package, just in case you're ever asked to work with code that uses it. Now, previously you learnt that the java.io classes work with streams, that is character and binary. Now data is read one byte or character at a time and sometimes buffered depending on which classes are used. Now when using java.nio, however, you'll deal with data in blocks, and rather than processing a single byte or character at a time, one block will be processed at a time. Now to accomplish this, you'll need to use channels and buffers, and you'll see what they are and how to use those in later videos in this section in the course. So with all that said about java.nio, you can use java.nio methods to create a java.io stream. But more on that later. For now though, make a copy of the adventure game project that we've been working on in this section of the course that we last used to read and write the data as an object stream. In other words, before we looked into random access. Now to save you a bit of time, I've put a zip file, a link to the zip file in the resources section of this video of the appropriate zip file for that video, just to save you a bit of time. Alright, so I've already unzipped that particular file and put it on my computer, so I'm going to switch back now to IntelliJ and we'll open it up and we'll get started with java.nio. Alright, so I've already got the package. I've actually unzipped it and I'm using the input, well I've actually called the folder input output NIO, so I know that it's different and distinct to the other projects. I'm going to open that. And we're going to start making some changes to this to support java.nio. Alright, so now that we've opened that other project, let's just quickly run it just to make sure that it still works. And of course it should work just fine, but it's good for us to check that. It's looking okay, so I'll exit out of that. Alright, so now that we've done that, let's start working with java.nio. Now, the first thing we're going to do is update the locations class so that it reads data from the directions_big.txt and locations_big.txt files. Now, these files are text files, as you recall, and we've done this many times now, but you'll first run the locations.main class to write out the data, and then we'll change the locations class static initializer, which loads the data when the first instance of the locations class is created. And then once that's done, we can call the main method from the main class to run the game. Alright, so let's go to our locations class, and the first thing we're going to do is delete the code from the locations.main method. So I'm just going to delete all that out, and I'll delete this comment out as well, and we'll get started. So we're going to start by typing path, noting that that's a java.nio, or it's from the java.nio package, and lock path for location path is equal to file systems. And we'll talk about this as we go through, but again, file systems is another java.nio package or class. File systems dot get default dot get path. We're going to put in the name of the file, locations underscore big.txt. And we'll do the same for the directions. So dir path is equal to file systems dot get default dot get path. This time it's going to be directions underscore big.txt. Then we're going to try with resources. So it's going to be try. It's going to be a buffered writer lock file equals files dot new buffered writer dir path. And then the second one is going to be, actually that should be lock path, the first one. We're opening or using both the files, so we need to have a buffered writer set up for both. So buffered writer, this one's going to be dir file is equal to files dot new buffered writer, and it's going to be dir path this time. Then we're going to go through and loop through all the locations. So for location, locations.values, then lock file dot write, and it's going to be location. Should be location there. The variable name, so it's going to be location dot get location ID. We're writing that out plus a comma plus the location description, so location dot get description. I'm going to add an end of line character to the end of that, /n. And the error we're getting at the moment is a typo. That should have been one there, one right parentheses and not two. Let's fix that up. And then we're going to go through all the directions, all the exits. So for string direction, colon, this time it's going to be location dot get exits dot key set. Then we're going to do a test to make sure it's not the default location. So if not, direction dot equals ignore case q. Then we're going to do a dir file dot write, and we're going to write the location ID. So location dot get location ID plus a comma plus the direction plus another comma plus, and we'll just go to a new line for this. And it's going to be location dot get exits dot get direction, and then we're going to do an end of line character, and that should be it. And then we just need our catch. We're just going to catch an IO exception, and if we happen to get an error, we're just going to print out the message IO exception e.getMessage. Alright, now what I'm going to do is just paste in the code that we used when we wrote the file using the java.io.bufferedReader, just so we can see the difference, even though we ultimately aren't going to use that. And I'm just going to include everything but the final catch. So this is what we did. Even though it's at a different indent level, we should still be able to get the gist of it here. So we're comparing the code starting on line 22 to load the code that's starting on line 35. So all that's really changed is the way that we create the buffered writer. Instead of creating one directly by calling the buffered writer constructor, which we've done here on line 35 and 36, we're using the java.nio.files class to create the instance. These files here, files.newBufferedReader lock path on line 22, and the same for line 23. So the files.newBufferedWriter method accepts a java.nio.path instance, and we obviously declared those a path instance on lines 20 and 21. Lock path and dir path. Now we are going to look at the path and the file systems classes in more depth later when you learn how to work with the file system. For now, just understand that the path class is meant as a replacement for the file class. So it's a more robust class when it comes to working with files. Now classes in the java.nio package work with path instances and not file instances. It's recommended practice to work with the path class if using java.nio wherever possible. Now sometimes you will have to use the file class, and that's because a method or constructor wants the file instance as a parameter, but when you do have a choice, make sure you use path over file. So creating a buffered writer this way creates a writer that uses java.nio to do its output. Now remember that the buffered writer wraps another IO class. So when we use the files.new buffered writer here on line 22 and line 23, a buffered writer is returned that performs I/O using an instance of the java.nio class called bytechannel. And you'll learn more about channels later in this section of the course. Alright, so let's get rid of that extra code that I copied and pasted in. Clean this up a little bit. Alright, so what we can do now is we can actually run this class, or run this method rather, locations not main. And you can see that it seems to have processed something. And if we have a look at the files, it's still pretty much as, directions underscore big was one of them. And also locations underscore big. They were the two files. And they're pretty much like they were before. Now the situation is the same when reading from a stream. So what we'll do now is we're going to update the static initializer so that it uses the files.newBufferedReader method to create the buffered reader. So the actual method will want a path instance. So looking at our static initializer, I'm just going to delete all that code out. And we'll just start again. So we want our two paths. They're going to be pretty much the same as they were prior to us changing the code here. Or after, I should say. So we want those two paths again. Then we're going to do a try. Scanner is equal to new scanner. And it's going to be files.new buffered reader. We're going to start with lock path. We're going to accept an import. And we're probably getting, we're getting a java.io.io exception, but we'll look at that shortly. So we're going to do scanner.use delimiter a comma. And let's fix this up a little bit. And actually what I was trying to do there was a try with resources, so I'll fix it up like that. Tab that over and put another right curly brace. Okay. And we've still got our IO exception there that we need to fix. Right, so we've got, or specified the scanner is going to use the delimiter of a comma. So we're going to go through now, so do while scanner dot has next line. Int lock equals scanner dot next int. Scanner dot skip, we'll be talking about this shortly. That's going to be scanner dot delimiter. String description is equal to scanner.nextLine. We're going to print it out and we'll put we'll type it out as imported location plus lock plus colon plus description, so we can see some output on the screen. Then we're going to do locations.put lock, their new location, and it's lock and description as the two parameters. Then we need to put a null there, and that's because our code at the moment, if we look at our constructor, we've talked about this previously, it's got the code built in to test to see whether null's passed, and it's going to create a new linked hash map for our exits if it has. Otherwise it'll just save the value of, or save the map if one was sent to this method. But in our case that's not happening because we're not passing that. So we'll go back to our locations code, leaving that as null. And what we still need to do is, I'll just finish this off so we've got at least got it catching some errors. IO exception E, then we're just going to eat.print stack trace. So what I'll do is I'll finish the video here now. When we come back, we'll actually add the code using the files.newBufferedReader, and this time we're going to add it for the directions, i.e. the exits, and actually add those as well. So I'll see you in the next video.